Chapter 2, Section 2, we're moving on to surface area. But in this video, the Apprentice video, we're actually going to touch on perimeter first, which is different than area. And hopefully you know, well, what perimeter is. And that is just the length or the total distance along the outside edge of the object. So number one, I have a quarter circle, and we're told that it has a radius of 13 centimeters, and we want to know what is the perimeter. Okay. So a quarter circle, so that means that is 13 centimeters. So is this. Okay. But in order to find the perimeter, well, I have to add 13 plus 13, but I also have to calculate this distance here. Okay. So hopefully you know how to calculate the outside edge or the perimeter of a circle, which is called the circumference, and there's a formula for that involving pi. So let's do that. Okay. Now we only need the length of this arc right here. So if I imagine a complete circle, it's not really there, but I'm just pretending that it is. Okay, I could calculate the circumference around the entire thing quite easily. My drawing's not that great. Good enough. And I know that the circumference of a circle is 2 pi r. Okay? Or you could also write that, since the radius, when you double it, is just the diameter. Another way of saying the same thing is pi times d. So you may have seen both of these formulas before. Okay, so we have 2 times pi times 13 centimeters. Now whenever you're working with pi on a scientific calculator, you don't have to punch in the number 3.14. If you look on your calculator, it should have a pi button, and it'll give you a much more accurate estimate of pi. So 2 times pi times 13, plus it's less to type. So you get approximately 81.68, and this, of course, is in centimeters. So that is the circumference around the entire thing. But remember, I only want this piece right here. Well, hopefully you can see that this is just 1/4 of the entire thing. So if I want the length of this arc, I just take this number and I divide it by 4. So with this still in my display, I haven't even cleared it yet. I'm just going to hit divide 4. And sure enough, I'll just label it here, I get 20.42, that is centimeters. Okay, so now I have everything that I need. So I'm going to take this number and I'm going to add 13 to it twice. Okay, so my perimeter is, I'm going to work vertically so I don't spill into my space over here, plus, so I'm just showing my work. And you get 46.42 centimeters. So there we go. There's the approximate perimeter of this quarter circle or wedge or large piece of pie. Number 2. A right triangle has a base and height of 5 inches and 6 inches respectively. What is the perimeter? First off, what does respectively mean? It just means that they match in order as they appeared in the problem. So base was mentioned first, height second, so this first number is the base and the second number is the height. That's all they mean by respectively. So the perimeter, I just need to find the lengths of all 3 of these sides and add them together. Well, 2 of them are already given. We're told that the base is 5 inches and the height is 6 inches. Now it's very useful, the fact that we're told it's a right triangle, which means this is 90 degrees. Well, we need to figure out this length. And you should know how to do that. It's quite simple because you would have been exposed to the Pythagorean theorem. So that is a squared plus b squared equals c squared. Okay. Now a and b is 5 and 6 or 6 and 5. The order doesn't matter. What's most important though is the c squared, the one by itself. That has to be this length. It's called the hypotenuse, and we square it. So I'm going to call that c. Right. So let's work it out. I know we're in inches, so this is 5 squared plus 6 squared equals c squared. Okay. I've left the units out of the problem. I just have to make sure to put them back in at the end, but I know everything is in inches. So this is 25 plus 36. That's equal to c squared. Okay. And if you add those together, you get 61 is equal to c squared. But I don't want c squared, I want c. So what number squared is 61? Well, to reverse that, we just simply take the square root. So the square root of 61 must be c. And you can use that in your calculator. So take the square root of 61 and you get, let's see, not a nice number, but you get 7.81, and that's approximately equal to c. Okay, so now we have all the information we need to find the perimeter. So P for perimeter equals, so I'm just going to take this number, it's still in my display, I haven't cleared it, and I'm just going to add the other two sides to get the total perimeter around the triangle. So plus 6 plus 5, and I get, it's approximately 18.81. And of course my final answer, I need my units. You should not have inches squared. Okay, this is not the area. This is just the length around the triangle. So it's about 18.81 inches. All right, areas using Pythagoras' theorem. Number 1, determine the area of the trapezoid. So we have to do a little bit of problem solving. And we have a trapezoid here, and some of the dimensions are given. This length here is not currently given. But if you don't know how to find the area of a specific shape, if you can recognize, though, that really you can break it apart into some simpler shapes that you do know how to work with, there's nothing wrong with that. So if I just create an imaginary line, it's like I'm cutting into two pieces, I've just created a simple rectangle and a triangle up here. And we know how to find the areas of those. And in fact, this area down here, I can calculate right now. That's not a problem. Okay, I know the length of this triangle, or the rectangle I should say, and its height. The only tricky part now is to try and determine the area of this triangle. Now normally we would use 1/2 times the base, but if that's 15, so is that. But we also need the height. Uh-oh. That's what we're missing. We need this piece right here. And I think I can see how we're going to do that. If this is 15, so is this. But this, of course, is a right triangle. And I can use the Pythagorean theorem. A squared plus b squared equals c squared, and subtract them, and I can find this little bit here. I'll call this B. You can call it anything you want. All right, so let's work this out. Okay. Well, I know from the Pythagorean theorem that b squared plus 15 squared, remember we're in centimeters, is equal to 17 squared. Okay. So I'm just going to solve for b. So b squared, 15 squared, I can work that out, that's 225. If you subtract it from both sides, you're going to get 64. That's actually a very nice number because to find b, I just take the square root of 64. 264 is a perfect square. So I get a very nice answer of 8. Okay, so we're not done. Okay, but we've determined that this little bit here has to be 8, in this case 8 centimeters. So now we can actually find the area of this entire thing. So let's find the area of the bottom rectangle. That's just this length times that width or height, whatever you want to call it. So this is 15 centimeters times 10 centimeters. Okay, plus this area right here, okay, of this triangle. So that is 1/2 times the base of that triangle, which is also 15 centimeters, times the little height of this triangle, which I labeled B, and we just determined that to be 8. So that's also in centimeters. Okay, so I'm going to work this out. Let's see, so 15 times 10, that's just 150. That's pretty easy. And we get 210, but this is area. This is centimeters squared. So if you look at a shape and you want to find the area and it looks too weird or too complicated, maybe try breaking it up into some simpler shapes that you can work with and just add them together. Okay, because, again, that's the rectangular bottom. And then this piece here, hey, I'll make a triangle, why not? That was the triangle. And you put them on top of each other and you get a trapezoid. 2, determine the shaded area. So I have a circle here, and then I have an inscribed square punched out of it. Now I know it's a square. Well, it's kind of obvious that it's a square, but also these hash marks here, okay, that tells us that if this is 3 centimeters, this is also 3 centimeters. So we have a square. And it should be obvious to you that if you want to find this gray area, well, you can achieve that by finding the area of the entire circle and then just subtracting the square in the middle. And whatever's left over gives us this gray bit. So the area shaded equals area of circle minus area of square. Okay, I'm going to find the area of the square first because, well, that's the easiest. So this is 3, that's 3. So 3 times 3, of course, is 9. Oops. Just going to put a little square here. So the area of the square is just 9.0. This is centimeters squared. So once I find the area of the circle, I'll just subtract 9, and that's going to give me my answer. But I now have to figure out the circle. Well, if this is 3, so is this. But if you want to find the area of a circle, we can use this formula here, which you've seen before and you would have worked with before. This is pi r squared. Well, we need the radius. This is not the radius. It is not the diameter either. This is the diameter, right here, from corner to corner. So if I can calculate this distance here to get the radius, all I have to do is divide that by 2, because by definition, the radius is half the diameter. Well, you should see the right angle triangle hidden here. So to find this diameter here, which I'll label as D, we use Pythagoras. So I get 3 squared plus 3 squared. That's equal to the hypotenuse squared, or D squared. 3 squared is 9. Double that, you get 18. That's equal to D squared. So if I want D, I just take the square root of this, and I can work that out in my calculator. So working it out, you get approximately 2.24. That's approximately the diameter. Okay, so if I want the radius, I'm just going to take this number. I'm not even going to clear it. I'm just going to divide it by 2. So I get 2.12. That is the approximate radius. So that is the number I'm going to use now in this equation here to find the area of the circle. So area of circle is pi. So I'm just going to use the pi button in my calculator times 2.12, and this of course is now, that's centimeters, close bracket, squared. Okay. Make sure that the square is outside the bracket. If you forget the brackets, it's going to look like you're only squaring the centimeter and not this number as well. So I have this number still in my display. I'm just going to square it. I get exactly 4.5, but I'll multiply by pi, and I get approximately 14.14. This is area, so this is now centimeters squared. So that's the area of the circle, and this is the area of the square. So now let's just find the gray area. Right, so my area of the shaded region, okay, just going to take the area of the circle and subtract the area of the square. Okay, and I get approximately 5.14 centimeters squared. And there we go. So that is all of this stuff. So a little bit of basic geometry, but a problem this difficult shouldn't be too much of a stretch.